Okay, today's starter, it says a car accelerates from rest at a rate of 4 meters per second every second, or meters per second squared if you prefer, for 10 seconds, then hits the brakes and slows to a stop in 5 seconds. How far did the car drive? Okay, this is all assuming the car is going in a straight line and everything. So, given well, here's a road, and I'm going to write what's given along in a little picture. I like to draw pictures. So here's my little car. So V naught is equal to 0, and then it accelerates forward with an acceleration of 4 meters per second squared. And we want to know, here's the first part, here's the car at t equals 10 seconds. Okay, then it starts hitting the brakes. So this is the end of part 1. So I'll even call this, I'll just call this delta x1. So you need to use all this stuff for delta x1. Then you hit the brakes, and then 5 seconds later, now do you want to call that t equals 15? You can, but I'm just going to say, I'm going to start my clock over again and say that from here to here, at t equals 5 seconds, you know that your final velocity is equal to 0. Now, one thing is that if you draw a picture of what you know and what you don't know, if you draw it around a picture, it makes it a little bit easier to figure out what you're supposed to do sometimes. So we want to find, so anyway, we'll call this from here to here, this is delta x2. So let's solve. Well, first of all, my total delta x is going to be equal to delta x1 plus delta x2. So I got to figure these out, and then I can just add them together. And the main idea here is that when you have two different parts of the problem, when you have two different accelerations, you have to treat it as two different problems. So let's figure out what delta x1 is. Well, what do we know? Initial velocity, acceleration, time. Final velocity not given, final velocity not asked for. So which equation does not have final velocity in it? Okay, when you look on your little equation list, 1, 2, 3, it's the third one. So delta x1 will equal v naught times t plus 1/2 a t squared. Let me zoom out a little bit. Give myself a little room. So this whole term goes to 0 because the car starts from rest. So delta x1 equals 1/2 a t squared, 1/2 of 4 meters per second every second times the time is 10 seconds, and we got to square that. So that's 100 times 2. That's going to be 200 meters. The seconds and seconds cancel there, leaving just meters. Is that right? So you're going to go 200 meters. Now, that's from here to here. Now, how far are you going to go from here to here? Well, what do I know? What do I not know? I know the final velocity and I know the time. But that's not enough. I need to know 3 things. Now, what is in every equation? If you look at the kinematic equations we've been using, what is in every single one of them? V naught. So V naught's not given here. So we have to figure it out. But here's the trick for this problem, and it's obvious when you look at it, when you think about it. The final velocity for the first part of the problem is the initial velocity for the second part of the problem. Doesn't that make sense? So if I can figure out what the final velocity is over here, I can call it V naught for the second part. So I can use, I don't want to use delta x, so I just want to find the final velocity. So I'll use the first equation. And v naught for part 1 is 0. And this is going to be 4 meters per second every second times 10 seconds. So our final velocity is 40 meters per second right here. But that means for part 2 of the problem, v naught is equal to 40 meters per second. Okay? And there's a problem just like this on the test, where it's got 2 parts to it. So, now what do I know? I know v naught, I know time, I know the final velocity, and I'm trying to find delta x. What's not asked for and not given? The acceleration. So which equation doesn't have acceleration in it? You look on your little list. It's the second one. Gosh, I have them memorized. Okay, I've only been doing this for 20 years. But you're allowed to have an equation list when you're working these problems. So use it. Use that little chart I gave you. It'll help you find the right equation to use. And so you say, okay, well, delta x2 is equal to v naught plus v over 2 times time. So make sure that you always write down what equation you're using before you plug numbers in. That way you can get lots of partial credit. So that's going to be, now v naught is 40 plus our final velocity here is 0. And then times time, 5 seconds. So 40 divided by 2 is 20. 20 times 5 is 100. So 100 meters. So delta x1 was 200 meters. Delta x2 was 100 meters. So our total delta x, we just add them up, is 300 meters. That's how far the car went. Okay. Any questions? Okay, very good.